What if we could build a virtual assistant that could help us manage our social media content creation? Well, in this tutorial, I will show you how I have built a social media manager that helps me keep track on when to post specific content items, on what platform and about what topic. It even can help me writing a first draft of it. So if you want to learn how to do this yourself, then definitely keep on watching this tutorial. Hi everyone, my name is Lore van Oudenhoven and I'm on the journey of building my own AI startup called Parrot. Throughout my tutorials, I'll take you along as I discover new techniques and technologies on how to provide solutions for clients. In this tutorial specifically, I will show you how I build a social media manager using LangGraph. More specifically, we will focus on the long-term feature that has recently been released by LangChain. So if you're interested in learning how to build this yourself, then keep on watching. So in this tutorial, we'll be using LangGraph, which is a framework to build AI agents that has been designed by LangChain. I have already created an extensive tutorial on how LangGraph actually works, so I will only briefly touch upon the basics here, and then we'll dive deeper into the long-term capabilities of these LangGraph agents. So LangGraph is a framework that allows you to build AI agents and basically comprises of three components: nodes, edges, and state. The nodes are basically the tasks that can be executed by a AI agent. So here in this example, we have a main agent node that interacts with the user. And then we have another tool node, which computes an energy cost based on the conversation that was had with the initial node. Then we have edges, and those are basically the flows between nodes. Edges can also be conditional, as you can see here. So depending on the input, it can redirect the conversation to one of different nodes. And then the state is basically the kind of memory of the conversation. We will get a bit more in depth in that later, but basically the state keeps track of the conversation and acts as a kind of memory. So now we will dive a bit deeper in the long-term memory. Most AI chatbots, they're only relying on short-term memory. With this, I mean that the AI chatbot can keep track of what has already been said during a single conversation. And this is something that is being handled in LangGraph using so-called checkpointers. However, if you have multiple conversations with an AI agent, you preferably also want that the AI agent knows what you have already said before. For example, if I already explained who I am, what kind of tone I want to use when drafting an article, that is information that we want to store long term. If you have been using ChatGPT in the past, you will have noticed that a couple of months ago they added a functionality called memory. Basically, this is exactly what this is. So the memory keeps track of things that you have said during previous conversations in a way that the AI agent knows things about your user profile, about your preferences. And this is then what we call the long-term memory. And the long-term memory is saved in a memory store. So by combining both the short-term memory with the checkpointers and the long-term memory in the store, we have a large language model that keeps track of your user preferences over multiple conversations. And that is exactly what we will do in this tutorial. We will build an AI agent that has this short-term memory aspect as well as the long-term memory. And in our long-term memory, we will store two very important components in this AI agent. First of all, the user profile as well as the content calendar. Both will be stored as Pydantic schemas with different fields storing the information related to that specific component. So for example, in our user profile, we want to store information about the user, such as its name, where it's based, the target audience, and the preferred social media platforms. On the other hand, we will have the content calendar, where we will store information about the title of the piece of content, the platform where we want to publish it, the deadline, the status, some tags, some keywords, and some draft IDs for the piece of content. A big difference between these two memory components is the fact that the user profile comprises one memory, so technically speaking, one JSON with 4 fields, The content calendar, on the other hand, is a list of different pieces of content. And by this I mean that we can, for example, have 3 content items with every one of them having a title field, platform field, and so on. So basically the content calendar component is a list of memories, a list of JSONs that can be updated with new information, or new items can be added to this list of memories. Okay, with this information in mind, I think it's good to take a look at the code already so that we can see how these Pydantic schemas translate in actual Python code. And so I have prepared a Google Colab notebook with all the code needed to build this long-term memory AI assistant for content creation. I will share the link of this notebook in the description below, so feel free to follow along. Before initiating, it is important to note that there are a couple of variables such as my LangChain API key and my OpenAI API key that are not shown in here, but you can add them as well by adding them here in the secret key store of Google Notebook. So just here add your own OpenAI API key and LangChain API key. Okay, so first of all, we need to install some of the packages that are needed to build our AI agents. We will do this by running pip. Next, we will then load in all these dependencies. We will also load in the API keys that we just provided. And then we can start working on our memory part. So as I just explained, there are actually three important memory components. 2 that I already described were user profile and content calendar, which are both Pydantic schemas. And then we also have a guidelines prompt, which stores information on the tone that should be used, the style that should be used when writing a piece of content. So in this code block, we will define these 3 memory components. First of all, we have the user profile, which, as I mentioned before, is based on a Pydantic schema. So as you can see, base model is loaded in from the Pydantic package here. Same for fields, actually. So in this profile, we define a name. The name will be a string. Also, this will be an optional parameter, meaning that if the user is not providing its name, that's not a problem. It will not run into an error because it's an optional field. Then we will have the field with description that this is the username, and we won't provide a default because, of course, it is an optional parameter. Then the same for the location, also an optional string, which defines the user's location. Same for the target audience, where we define the target audience for our content creation. And then we have the preferred platforms, which is a bit different because here we provide a list of strings, which means that we will simply have a list of potentially multiple platforms that are stored in this field. Next up, we have our content calendar schema. Again, a Pydantic schema with multiple parameters such as the title, which is a required field, as you can see here. Then the platform, again a string. Then the deadline, which is not a string but a datetime. Then the status, which is again a list, but here we provide a defined list of options. So the status can only be either an ID, a draft, a review, or posted. Then we have tags, which is again a list of tags or topics that is associated with this content item. And then ID, which gives like the general ID of this piece of content. So as I mentioned before, our profile will be one memory. So we will only have one JSON with a name, location, target audience, and preferred platform. The content calendar, on the other hand, will be a memory collection, meaning that we can have multiple JSONs with these 6 items. And each JSON then represents one piece of content. So we can have a piece of content that lists a Medium article with the title AI Agents for Dummies that will be posted next Friday. And then we can have another item called Large Language Models in Healthcare, which will be published next month, Friday. So in that way, we then get like this list of different content items. And then we have a prompt, which can be updated throughout the conversation with the AI agent. And basically in this prompt, we will inject any type of guidelines that is given by the user throughout the interaction with the AI agent. So now that we have defined our memory components, the next thing that we need is a way to update these components, because throughout a conversation we can define, for example, that we want to publish an article next Friday. But then we realize that next Friday won't be possible, so we want to change the date to next week Monday. How are we technically going to implement that this content calendar item is being updated from Friday to next Monday? Well, one library that helps us with that is Trustcall. Trustcall is a Python library that can manage these Pydantic schemas or these JSONs in a way that it checks whether specific items need to be updated or new ones need to be created. And basically the way it works, when a user interacts with the AI agents and mentions something about an item that has already been stored in this JSON, Trustcall will check, okay, what information is already stored and the new information, is it something that we should update there? And the main function that we will use from Trustcall is the create extractor function. So please skip for 1 minute this class here, but focus on the profile extractor first. So this profile extractor is actually the create extractor function from our Trustcall library with then as input the model. We will use here GPT-4o. Then we define our tools or the memory components, which in this case is our profile scheme, so this class here. And then we also need to add the name of our tool, so in this case profile. So for this profile, it's quite straightforward because, as I mentioned, the profile only contains one JSON. For the content calendar, on the other hand, it's a bit more complicated because there we have a memory collection, so multiple content items with all different keys regarding the name, the date, and so on. So here it's a bit more different. We also have the create extractor function from our Trustcall library. Then we define the model, the name of the tool, and then we enable inserts. The reason that we enable inserts is because this create extractor, it actually allows us to insert new items into a scheme. Before, with the profile extractor, we didn't need to add any additional items because it's just one item defining a profile, but here we want multiple content items. And by enabling inserts, you not only allow the Trustcall package to update items, but also to create new ones and basically create a list of content items, so a memory collection. The other thing that is different is the with listeners function with then the spy class, which we just skipped before. And the reason for this is to extract information that is provided by the Trustcall. So Trustcall will provide us with a lot of details on what specific updates or new items have been added to the JSON schemas. But this spy class helps us to extract the information that we actually need. So you can fully customize this spy class, but I think it's more convenient to show you how it works. So in this section, I have provided an instruction to extract information about the content calendar during this conversation. Then here I will mimic a conversation with the AI agent. We will start by introducing ourselves, and then we'll mention that we want to write a Medium article about LangGraph AI agents. So here we will invoke the content extractor and we'll provide it messages, which is a combination of a system message, so that is the instructions that we have defined here, as well as the conversation. So we will now run this. And in this result, we can see that there was a tool call being made towards our content calendar with this call ID, and then here the argument. So these are a couple of the arguments that we have defined in our content calendar schema. So we have a title, LangGraph AI Agents. We have a platform, Medium. The status, it's an ID because we haven't provided any content. Then some keywords and the ID itself, where it states an article exploring the capabilities of LangGraph AI agents. So that is all extracted based on the conversation that we had provided here. So this is all provided by the content extractor. which gives us insights in what the Trustcall tool is changing to our memory components. So in this case, the content calendar. And then we can evaluate our spy class, which gives in a JSON format exactly what has been happening. So here you can see that again, this piece of content was added to the content calendar with this specific ID. So say that we now continue interacting with our agent and we give extra information about this content item. For example, we say we want to publish it next Friday. Okay, what we do here is we'll retrieve the existing memory from our previous interactions. So from our results, we extract the previous responses. So in that way, we have the new conversations added with the existing conversation. And then we again invoke our content extractor with the updated conversation, and we provide the existing memories as well. When we now run this content extractor and evaluate the results, we can see that again a tool call was made to the content calendar, but now we can see that also a deadline was added, actually next Friday as a deadline. Besides that, we can see that the rest of the items remains intact, which means that a patch or a change was made to this JSON object. And that is what we will exactly be able to observe with our spy class. If we run this, we can see our earlier call, which is indeed exactly the same ID than here. But then we also observe that there was a new item added to this spy called tools list, which is called patch doc, meaning that our JSON document has been patched or updated. Here we can see that the JSON doc ID was 0, which is exactly this item. And the planned edits was that there was a deadline added, which was set to next Friday. So here we can see the patch with path deadline set to this date time. And here we get the ID of this update. So in this way, we can keep track of what changes have been made to the content calendar or any other memory components. However, you can also see that this JSON structure is not ideal if you want to provide it as information to our AI agent. And because of that, we will create a function that reformats this in a human readable way, or actually a more LLM readable way, so that our large language model also knows what changes have been made so that it can report it back to the user. So for this, we will define the function extract tool info, which takes as an input the spy.tool calls and then restructures it based on whether it is a patch doc. So like in this example, if that is the case, it will create this item update with all the information about the document ID and the planned edits. If not, it will create a new item, and then it will reformat this information as a single string. So to illustrate this, we can run this function, and here you can see that the spy.called tools from before, which was structured like this, is now reformatted in a more readable way, where there is a first item, new content calendar created, with then all this information, and then a second item that updates document 0, and then it states that the deadline was added, which is set to next Friday, and then here the deadline that was actually added. Okay, so that was everything regarding memory management. In the next section, we will dive into the graph or the AI agents itself, where we will define different tool nodes and edges and combine them into one AI agent. So before that I dive into that specific code, I want to give you an overview of the AI agent and how it will actually look once we have compiled the full graph. So basically we will have one main function, the content generator function, which is the orchestrator of this AI agent. This function will decide whether an update should be made to the content calendar memory, an update should be made to the guidelines, or an update should be made to the user profile. So this is all dependent on the user input. The content generator has a system prompt that tells him to evaluate the user's input and check to which of these tool nodes it should be redirected. This is also using kind of a router function to then direct to the correct node. Each of these nodes then performs the required updates, so updates to the memory as we illustrated, or updates to a guideline prompt. And then after each update has been completed, we again are redirected to the content generator. And in that way, we keep on having this conversation between a user and the AI agent. So when we walk through this code, keep in mind this schema. It will help to structure a bit the layout of our AI agents. Okay, so we will start by defining our content generator function. So the main function that will redirect to the appropriate tool node. And before we define the function itself, I want to create a new class called updateMemory. This is actually to save whatever decision the content generator has made. So as I just mentioned, the content generator can decide either to update the user profile, the content calendar, and the guidelines. And this object is basically storing that decision. So then the content generator function itself, it takes as input the message state, a runnable configuration, and the memory store. So first of all, we will obtain the user ID from our configuration file. Then we will retrieve already existing memories from our store by searching for the user ID that was in the configuration. Then we will obtain the user profile if this is already available. So with the user profile, I mean the ones that is stored in the JSON Pydantic schema with the 4 different fields. Then the same is done for the calendar contents. Again, the store is searched, but this time for the content calendar of the specified user ID. And then it will join all the items in this content calendar. And then we have the same for the guidelines. The store is searched for guidelines if they are existing. And then we will prepare a system message. The system message is a dynamic prompt with 3 inputs. So the user profile, the content calendar, and the guidelines, which we have retrieved from our store, our memory store. Let me first walk you through this system message. So it's quite a long prompt that is a bit structured in different parts, but I first want to show you the dynamic input of the user profile, the content calendar, and the guidelines here. So what we have retrieved from our memory store will be inserted in the model system message on these locations. So what does this prompt say? First of all, it sets the stage, right? It tells the large language model that it is a helpful content creation system and that his role is to help the user brainstorm, organize, and track content IDs for different platforms. And then we say that there are 3 types of memory. We have the user profile, content calendar, and guidelines. Then we insert the current user profile, the current content calendar, and the current guidelines. Next, we will define the instructions for reasoning about the user's input. We will tell the large language model to carefully reason about the user's messages as defined below. And in step 2, we will give it instructions on how to handle the long-term memory. If the message of the user contains personal information, then we should update the user's profile by calling the updateMemory tool with user. So remember, the updateMemory tool is defined here, and whenever the large language model gets information about the user profile, it will set this updateMemory to user. Secondly, if content ranges are mentioned, then it should call the updateMemory tool with type content calendar. And thirdly, if we provide information about specified preferences on how to update the content calendar list, then we will update the instructions by calling updateMemory tool with the type guidelines. So in this step, we tell the large language models how it should use the updateMemory tool. Next, we will provide information on how the large language model should reply to the user. We don't want it to tell the user that you have updated the user profile. So, for example, if I'm interacting with the AI agent and I tell I want to publish on YouTube, then we should change that in my user profile schema. but we don't want the large language model to say that I've updated this profile. On the other hand, we do want the large language model to tell when there were updates to the content calendar memory component, but we again do not want them to tell anything about the updates of the guidelines. So only when we make changes to our content calendar memory component, the large language model will provide that information. And if you recall from before, that information will come from our SPY tool calls that is extracted from the Trustcall updates. Then we have a fourth item saying that it does not need to add for explicit permissions to change anything to the content calendar. And then we would just want to tell to respond naturally to the user after a tool call was made to save any type of memory change, or if no tool call was made at all. Okay, so that was the first step. So now with this function, we are able to decide what type of update that should be made. So we know whether we need to go from content generator to update user profile, update content calendar, and update guidelines. And we can use this in our router. So this route message function will, based on the last tool call, so whether this update memory was set to any of these three items, it will decide whether to proceed to the update profile node, to the update content calendar node, or the update guidelines node. The next thing we need to do is to define these three nodes. So here we have the update profile node, which has the same inputs as the content generator node. We will again extract the user ID from our configuration, and using that user ID we will set the namespace to the profile with a user ID that is specified. In the next step we will retrieve the existing profile memories. So what we will do is we will access the store, the memory store, using our namespace that we just retrieved based on our user ID. Next, we will then extract our memories from these existing items that are in our store using this line of code. Basically, what it does is for each existing item, it will loop through it, extract the item key, tool name, and item.value. Once that is done, we can update our Trustcall instruction, which we have specified here. The Trustcall instruction is an instruction that we provide to the Trustcall tool to mention that it should retain any necessary memories about the user, and we provide it as a dynamic input the time. So that is exactly what we will do here. We will set the time to datetime.now. Next, we will merge our instruction, our Trustcall instruction, with our chat history. And the way we do this is by running this predefined function merge message run and combining the Trustcall instruction as a system messages, and then the previous set of messages from our chat history. We can provide it by getting the message key from our state, which is an input of the function. And then in the next piece of code, we get to our profile extractor. And if you remember from before, this function is actually the function that looks for any updates that should be done to our memory component profile. So to invoke it, we provided the updated message lists, which include the Trustcall instruction, as well as the existing memories, which we obtained from our memory store. Then we parse the result by retrieving the response as well as the response metadata. And if you remember from before, the response metadata includes the doc ID if this memory was already existing before. Next, we go ahead to put this in our memory store. We define the namespace, and then from the metadata, we provide the JSON doc ID if available. If not, we provide a new UUID. And then we parse our response in JSON formats, which you can see here. So now our store includes any updates that have been provided by the profile extractor. And then we return the message to our AI agent that we have updated the profile, and we also add the tool call ID here. Okay, that brings us to our next function, which is the update content calendar functionality. It has the same inputs as the update profile tool. And again, we will extract the user ID from the configurations. In that way, we can obtain the namespace. We will access the store, the memory store, to obtain our existing items and merge the Trustcall instructions prompt with those messages. And now we will call the content extractor again with our updated messages and our existing memory. And if you remember from before, this content extractor is slightly different from the profile extractor because it has to account for a list of memories or a memory collection rather than one memory. Once we have the result, we can loop through it and put everything again in the store with the metadata, so the JSON, doc ID, and the actual result content. What is a bit different here is that we will now return a message with a variable called content calendar updated messages, which we obtain by running our extract tool info function, which we defined before. And if you remember, it has as an input the spy class with the called tools and then our tool name, which is content calendar. So what this does is it actually reformats everything that was tracked by our spy class in a more readable way so that we can use it as an instruction or an input to our AI agent. So that's the only difference between the update profile tool and the update content calendar tool. And that brings us to our third tool, which is called the Update Guidelines tool, again with the same input parameters as the other two tools. You will see that this function is a bit simpler, and that is because here we're simply updating a prompt rather than adding items or updating items in a memory component. So again, as similar as before, we extract user ID from our configurations and obtain the namespace. From the namespace, we then get the existing memory for this content guidelines component. And then we go ahead and update our system message by integrating the existing memory into this create instructions prompt, which we have defined here. As you can see, this is again a dynamic prompt where the guidelines are inputted here. Then we invoke our ChatGPT model by providing a system message, which is the system message that we defined here, as well as our chat history, and a human message, which is stating, please update the guidelines. And then we update our store by providing the new memory content, which we defined here. Okay, and then the output of this message is similar as before, where we provide as a content that we updated the guidelines, and we also provide the ID of the tool call. So now that we have defined all the nodes and the router, we can go ahead and finally compile our graph. I will first show you again this structure of our graph. So once we initiate our agent, we will be directed to our content generator, which then using our router functionality will bring us to one of these tool nodes. And the arrows that you can see here are the edges. When you see a dotted line, it means that they are a conditional edge because it's decided by the router function which of these four dotted lines will be called. Okay, so let's start by initiating our graph by running the state graph function with the message state component. And then we will add our nodes. So as you can see here, we have 4 nodes. We have the content generator node, the update profile node, the update content calendar node, and the update guideline nodes. And then we need to define our edges. So our first edge is between the start of our conversation and the content generator, which you can see here. Then the second one is a conditional edge between the content generator and the route message. These are actually the dotted lines that you can see here. And so the route message will define which of the 3 nodes we will proceed to. And all these 3 tool nodes, they are again linked to our content generator, which means that our agent keeps running in a loop where we start at the content generator, go to the route message, then to one of the tool nodes, and then back again to the content generator. Next, we need to provide our memory stores. So we have 2 memory stores. First of all, we have our cross-thread memory, which is the memory that contains our profile, our content calendar. So basically contains all the metadata that is gathered throughout the different small conversations. And for the conversations itself, so the within thread memory, we have the memory saver, which allows the AI agent to have a history of what is already being said during one conversation. And then in this compile code, we add this within thread memory as a checkpointer and the across thread memory as the store. And then we can compile this, and using this compiled graph, we can then again recreate this image, which gives a nice visualization of how the AI agent works. Okay, we have everything set in place now. The only thing that is remaining is testing our AI agent. And we can use this code to do so. So first of all, we need to set our configuration. In this configuration, we will define our thread ID. So this is basically the conversation ID. We give it ID 1 for now, and we also provide our user ID, which is my name, Lode. Then we start by creating a first human message, which is my name is Lode, I live in Ghent, I have 2 cats, I write articles for Medium and create YouTube tutorials, mostly targeting developers that want to learn on how to build generative AI apps. Then we will run the graph by using the stream invocation. And so as message, we provide these input messages, our configuration, and then the stream mode we set to values. And with this pretty print function, we should get a nice overview of our messages. And indeed, here we see our human message, which I just read out loud here. And then we have the AI message or the reply, stating thanks for sharing. If you have any content IDs or need assistance with your content calendar, just let me know. Okay, that is nice. So we provided information about the user profile. So I have provided information about which platforms that I use, where that I live, what's my name is. So these should all be stored to our profile memory component. And we can check that by running this code. From the cross-thread memory, so the memory that is kept over all the conversations, we will search for the profile with my user ID, Lode, and then print the values. And here, indeed, you can see that my name is stored, my location is stored, my target audience is stored, and my preferred platforms are being stored. So here you can really see our profile component in action. Let's now do the same for our content calendar component, and we will add a message stating that I want to write an article about an AI agent to post next Friday. So this is an item that we want to add to our content calendar. Again, we can use the same code to interact with the AI agent. And here you can then not only see the reply of our AI tool, stating that the AI agent has updated our content calendar with an article about AI agents for next Friday, but also we see all the tool calls that have been made. So we have a tool call that updates our memory, more specifically our content calendar, and also an overview of the new content calendar items that have been created, which you can see here, a title, the platform, the status, it's still an ID, some keywords, some tags, and an ID. So this is actually the output that we get from our spy tools, which we then have reformatted with our custom written function. And here again, you can see the content calendar items, which have also shown up here. So say you now want to know what is on your schedule for next week, then you can ask the question, can you list all my content for next week? And then the AI message will look into its memory and see what items are scheduled for next week. And here you can indeed see that he retrieves our item that we have just added that is scheduled for next Friday. And more than that, we can also ask him to help us write a Medium article for next Friday. So by stating that we want a draft for the Medium article for next Friday, it already knows what it should be about. And based on that, it can then start drafting the article or the outline of the article. So that's it. We now have built an AI agent that we can use as a social media manager. Of course, there are many more functionalities that you could add to it, but this is really the basic backbone of a LangGraph AI agent. So I hope you learned a lot in this already quite complicated tutorial. If you liked this video, please give me a like and follow for more content about creating AI agents and chatbots. I will be posting new tutorials soon, so definitely follow me here and on my Medium profile where I write articles as well. Thanks for watching and hope to see you in my next video. Bye!